Download this code from codegive.com, link in the description below. OK, let's dive deep into event dispatchers in Unreal Engine 5. This will be a comprehensive tutorial with code examples covering various aspects, from basic usage to advanced techniques. What are event dispatchers? Event dispatchers in Unreal Engine are a powerful system for enabling communication between different parts of your game code in a decoupled and flexible way. Think of them as a publish/subscribe system. Publishers objects that trigger or dispatch an event. They don't necessarily need to know who's listening. Subscribers objects that bind to an event and react when it's triggered. They don't need to know who's triggering the event. Benefits of using event dispatchers decoupling reduces dependencies between classes. Objects that dispatch events don't need to know about the classes that are listening, and vice versa. This makes your code more modular and easier to maintain. Flexibility allows you to easily add or remove listeners without modifying the dispatcher. Code reusability you can easily reuse event dispatchers by other blueprints or code. Clean design promotes a more organized and less tightly coupled code base. Dynamic connections event binding can be done at runtime, which is useful for creating systems that respond dynamically to changes in the game. Basic example, simple event dispatcher, C++. Let's start with a very simple example in C++. We'll create a class that has an event dispatcher that triggers when a button is pressed. Another class will subscribe to this event. 1. Create a new C++ class ***. Create a new C++ class in your Unreal project. Let's call it my event dispatcher component. It should inherit from uActor component. My event dispatcher component.h**. My event dispatcher component.cpp**. Explanation declare _dynamic _multicast _delegate, F button pressed delegate. This line defines a delegate type named F button pressed delegate. Delegates are like function pointers, but they are type safe and can be bound to multiple functions, multicast. Dynamic _multicast means it can be used in blueprints. A property, blueprint assignable, category equals events. This declares an F button pressed delegate variable named button pressed event as a property. Blueprint assignable makes it accessible from blueprints for binding. Category equals events just helps organize it in the details panel. Button pressed event.broadcast, this is the line that actually triggers the event. Broadcast calls all bound functions. Simulate button press, this is a function that, when called, triggers the button pressed event. The blueprint callable specifier makes it callable from blueprints. 2. Create another C++ class, myEventListenerActor. This class will subscribe to the event. myEventListenerActor.h*. myEventListenerActor.cpp*. Explanation include myEventDispatcher component.h. We need to include the header file for the myEventDispatcher component so we can access its members. U function, void on button pressed, this declares a function that will be called when the event is triggered. The U function, macro is essential because it makes the function accessible to the Unreal Engine reflection system, allowing it to be bound to delegates. Dispatcher component button pressed event.add U function, this, fname, on button pressed, this is the crucial line. It binds the on button pressed function to the button pressed event dispatcher. Add U function allows us to bind the dispatcher to the on button pressed function. When the event is broadcast, the on button pressed function of this object will be executed. Asterisk get all actors of class, get world, a actor static class, found actors. This example uses get all actors of class to find the actor with the dispatcher component. This is a simple approach, but in a real game, you'd likely want to use a more efficient and targeted method to get the reference to the dispatcher component, example using get component by class if you know the actor has the component. 3. Using in the editor ***. 1. Add components to actors ***. Add a myEventDispatcher component to an actor in your level. 2. Add a myEventListener actor to the level. 3. Run the game ** in the level blueprint or another blueprint, get a reference to the actor with the myEventDispatcher component. Call simulate button press, on the component. You should see the message button pressed event received, in the output log. Blueprint event dispatchers, a simpler example. Event dispatchers are much easier to use in blueprints, and this is where they often shine. Let's create an example entirely in blueprints. 1. Create a blueprint actor ***. Create a new blueprint actor. Let's call it BP_event dispatcher. 2. Add an event dispatcher ***. Open the blueprint editor for BP_event dispatcher. Go to the My Blueprint panel, usually on the left. Under Event Dispatchers, click the plus button to add a new event dispatcher. Name it My Custom Event. 3. Trigger the event ***. Go to the event graph. Add a custom event node. Let's call it Trigger Event. Drag a pin off the My Custom Event dispatcher and select Call My Custom Event. This is how you trigger or dispatch the event. You can connect a key press event, example E key pressed, to the trigger event custom event to trigger it when you press E. 4. Create another blueprint actor, BP_event listener. Create another blueprint actor. This one will listen for the event. 5. Bind to the event ***. Open the blueprint editor for BP_event listener. In the event graph, add an event begin play node. Add a node to get reference to BP_event dispatcher. Get BP_event dispatcher from the level using get all actors of class, then use get to grab a reference. Drag a pin off the BP_event dispatcher reference. Type bind event to My Custom Event and select the corresponding node. This creates a binding to the My Custom event dispatcher. From the event output pin of the bind event to My Custom Event node, drag a wire and create a custom event node. Name the custom event something descriptive, example on My Custom Event Triggered. Connect something to the on My Custom Event Triggered event to show that it's working, example a print string node that prints event triggered. 6. Test ***. Place instances of both BP_event dispatcher and BP_event listener in your level. Play the game. Press the E key, or whatever key you connected to the trigger event in BP_event dispatcher. You should see event triggered, in the output log. Blueprint event dispatchers with parameters. Event dispatchers can also pass data to their listeners. Here's how to add parameters to a blueprint event dispatcher. 1. Modify the BP_event dispatcher ***. Open the blueprint editor for BP_event dispatcher. Select the My Custom event dispatcher in the My Blueprint panel. In the Details panel, under Input Parameters, click the plus button to add a new input parameter. Set the name of the parameter to message and the type to string. 2. Pass data when triggering ***. Asterisk in the event graph of BP underscore event dispatcher, select the Call My Custom Event node. Asterisk you'll see the message input pin. Connect a string value to this pin, example a string literal like hello, event listener. 3. Receive data in BP underscore event listener asterisk asterisk. Asterisk open the blueprint editor for BP underscore event listener. Asterisk select the On My Custom Event triggered custom event. Asterisk you'll see an input pin named message of type string. This is the data being passed from the dispatcher. Asterisk connect this message pin to the in-string input of the print string node. 4. Test asterisk asterisk. Asterisk play the game. Asterisk press the E key. Asterisk you should see hello, event listener. Or whatever string you used, printed in the output log. Advanced techniques. Here are some more advanced techniques for using event dispatchers. Asterisk event dispatchers in UMG. User interface event dispatchers are commonly used in UMG to handle button clicks, slider changes, and other UI events. Asterisk event dispatchers in actor components asterisk as shown in the first example, event dispatchers can be part of actor components. This is useful for encapsulating event logic within reusable components. Asterisk lambda functions for event binding. C++ in C++, you can use lambda functions to create more concise and inline event handlers. Asterisk removing bindings asterisk use remove or remove all to unbind functions from event dispatchers when you no longer need them, example when an actor is destroyed. This prevents memory leaks. You need to store the delegate handle returned by addu function, add lambda, etc. Asterisk checking if an event is bound asterisk use is bound, to check if there are any bound listeners. Asterisk blueprint implementable event and event dispatchers together asterisk you can combine blueprint implementable event and event dispatchers to create base classes where some logic is handled in C++, and further customization is done in blueprints using event dispatchers to trigger specific functions. Important considerations asterisk. Asterisk performance asterisk while event dispatchers offer great flexibility, excessive use can have a slight performance impact. Consider alternative approaches, example direct function calls, if performance is critical and the benefits of decoupling are not significant. Asterisk garbage collection asterisk when using C++, be mindful of object lifetime and garbage collection. Make sure that objects bound to event dispatchers are not destroyed before the event dispatcher itself is destroyed, or you may encounter crashes. Use T-weak object PTR or other techniques to manage object lifetimes. Asterisk avoid circular dependencies asterisk be careful not to create circular dependencies where event dispatchers and their listeners depend on each other in a way that prevents either from being garbage collected. Example, event dispatcher with T-weak object PTR. To prevent issues with garbage collection, especially in C++, consider using T-weak object PTR when storing references to objects that listen to your event dispatcher. This prevents your event dispatcher from holding a strong reference that could prevent the listener from being garbage collected. MyEventDispatcher component.h, modified. MyEventListenerActor.h, modified. MyEventListenerActor.cpp, modified. Explanation of changes asterisk. Asterisk T-weak object PTR my event dispatcher component PTR, we replace the direct pointer my event dispatcher component asterisk dispatcher component with a T-weak object PTR. T-weak object PTR does not prevent the object it points to from being garbage collected. Asterisk dispatcher component PTR equals dispatcher component, we store the found component into the weak pointer. Asterisk we can still access the dispatcher via dispatcher component PTR button pressed event. Using the weak pointer safely asterisk. Before accessing the object through the T-weak object PTR, it's a good idea to check if the object is still valid. This check prevents crashes if the dispatcher component has already been destroyed by the garbage collector. Summary **. Event dispatchers are a crucial tool for building flexible, maintainable, and decoupled game systems in Unreal Engine. By understanding the concepts and techniques outlined in this tutorial, you'll be well equipped to leverage their power in your projects. Remember to choose the right tool for the job. Sometimes direct function calls or interface implementation may be more appropriate if the decoupling offered by event dispatchers isn't necessary. Experiment and learn how to use them effectively in your game development workflow.